How's everybody doing out there? Well, welcome to day 24 of Corona Online School. So today we're starting into the final unit of the semester, which is going to be like rigid motions, transformations, glide reflections, all kinds of stuff. So it could be stuff you've never heard of or haven't, used that much. So the first thing I wanted you to do before we kind of moved on, and so normally if we were in class, I'd have you guys do this as a group, is just kind of jot down anything that just looking at these words, like thinking of anything that they might mean to you. If you've done this before, or even if you haven't done this before, take a guess, write down what you think a translation might mean, what a reflection might mean, what a rotation might mean, and just jot some words down to kind of go along with it. And then, so pause the video at this point, do that real quick. And then when you're done, come back and we'll actually go through and formalize all these definitions and stuff like that. All right, so hopefully you came up with some good guesses for translations, reflections, and rotations. So in the meantime, let's go ahead and actually fill out some of these definitions here. So I've got a PowerPoint slide to go with it. So I'm going to flip to the slide so we can kind of talk through it. And then you can, I'll have the slide posted so you can go back later and either write these in your notes later or write them in as we're going along now. So let me flip to the slide. Oops, slide real quick. All right. So we've got our rigid motions and similarity transformations here, day 1. And so a transformation is just what's called a one-to-one correspondence of the set of points in the plane onto itself. And so what it's doing is taking like this point P and moving it to some other point P prime, or in this case, it's taking Q and moving that point to Q prime in some manner. So like at this point, we're not talking about how the movement's going to take place. So that'll occur later. And so the image is always going to be the prime. So in this case, P prime and Q prime are the image. So that's wherever the transformation moved the point. And the P and the Q are what are called the pre-image because that's before they were actually moved in this case. All right, so today the only type of transformations we want to talk about are what are called rigid motions. And so another word for, like that, you can talk about isometry, which means it has the same measure. So what that means is it's not going to change shape. So like if we had a triangle here, like it's going to be exactly the same triangle over there. So it's not getting bigger, not getting smaller. So we will talk about that later, but not today. So today, everything we're talking about involves moving things around, but preserving the size of it and the shape. So in this case, an image is moved to a new position on a plane. It's rigid, therefore it does not allow for stretching or shrinking. So again, it stays the same shape and same size. So the initial and final positions are considered in the rigid motion. So typically what you're doing is you're thinking about like where you can move certain points. So like in this case, like if you were doing a triangle, you try to move those 3 vertices and then you just connect the dots in between. You're not necessarily trying to move every single point on this line. So you're just trying to find some key points to help you figure out, where it ends, based on whatever the transformation is. All right, so one of the first rigid motions we have is what's called a translation or a slide. And so what that's going to do is it's going to start off, in this case, so our blue is the pre-image, our red is the image. And so it's going to move it somewhere in the coordinate plane. So it could move it just right, it could move it just left, it could just move it up, it could just move it down, or in this case, it could move it, to the right and up. So, and that's kind of how they'll define it. So sometimes you'll actually see this defined almost like an ordered pair. So if you saw something like slide, some image 3, 4, then that would mean we would go to the right 3 and up 4. So sometimes you'll see that notation in relationship to a slide. So the one thing to notice about a slide is the picture looks exactly the same. It's like, I've got the A's over here, the A primes over there. So there's no flipping or anything like that. It's just a straight slide up and down. So it preserves the shape on this side and everything. So our next rigid motion is what's called a rotation or a turn. And so in this case, this is going to rotate this object around some center point. So almost always the center of rotation is going to be our origin, because that's kind of the easiest. But you can, technically you can rotate it around any, center point that you want. And typically for us, all of our rotations are usually going to be kind of the nice ones. So like 90 degrees, 180, 270, or 360. So again, it's not that you can't rotate it 45 degrees or 21 degrees or anything like that, but it's a little harder to do kind of the math on it. And kind of it always involves some trig and stuff like that. So for us, we're pretty much going to be sticking with 90-degree rotations. And so what I would recommend if you're actually struggling with this a little bit, usually what I do if I'm in class with you guys, I give you a transparency to use. But what you can do at home is take like a Ziploc bag and rip it in half and get like a dry erase marker. And what you could do is you could actually, so what I would do if I was doing this as a dry erase marker, so I would, or as a Ziploc bag, like I'd highlight these axes like this on my Ziploc bag, and then I would highlight the triangle that I'm interested in. And then what I would do is I would rotate this thing 90 degrees so that this point actually ended up there. And when you do that, we'll see that this triangle actually lands right on top of that. So this one is actually at 90 degrees counterclockwise. Oops. Rotation. Or it's a 270 degree clockwise rotation. So I could have gone this way and around and gotten the same thing. So that's kind of the cool thing about these rotations, because you always get kind of a mirror rotation. So if you've got a counterclockwise, there's always going to be a clockwise one that goes with it. And the degrees will always add up to 360. It's kind of the nice thing. So in this case, 90 plus 270 is 360. All right, everybody okay on rotation? All right, perfect. So a reflection is just a flip in this case. So again, it's kind of taken, if you imagine looking at a mirror and stuff like that, so that's what a reflection would do. And so notice in this case, our triangle looks different than it did from the slide. So again, remember our A was on the left, our A prime was on the left, but with our reflection, the A is on the left, but our A double prime, in this case, is on the right-hand side of the triangle. Same thing here, our C was on top, now our C is at the bottom of this guy. So again, depending on which way you flip them. So what you're doing is you're trying to take these points and kind of moving them this way. Same thing here, you're moving these points the same distance across that mirror line that you've got. And so in most cases, what we're going to do, and again, not that you can't translate over any line that's out there, but a lot of times what we're going to be doing is we're going to be, translating across, like this would have been like a translation across the x-axis. This would have been a translation across the y-axis. So again, you can do it over any vertical line, any horizontal line, and theoretically you can even do it across the diagonal line. But the majority of the stuff we're going to do is going to be across the x and the y-axis. All right. And so finally, the last type of rigid motion is what's called a glide reflection. And so this is actually a combination of a slide and a reflection together. So what you're going to do is you're going to do the slide first. So in this case, I slid from here to this dotted line. And then I used my mirror line to reflect that middle triangle to get my final triangle. So in reality, this is the red one is the final answer, but it doesn't hurt to put that middle triangle in there just so we can see that we actually did the slide correctly and stuff like that. So, all right, any questions about those guys? All right, perfect. So let's go back to the classwork packet now that we've got the definitions down. There we go. So practice 1, I want you to kind of look at those amongst yourselves and kind of figure out, is which one of these is a reflection, which one's a translation, and which one's a rotation, and you can just jot it down underneath there. And then from here, what we want to do is get in and actually talk about the different possible slides and how we, or different possible transformations and how we do them. So the first one we want to look at is a translation again. And so again, remember, every point of the plane's moved the same distance in the same direction. A slide arrow is going to tell you which way to go. So that's what this is here. This is our slide arrow. And it's going to tell us how we're going to move this blue figure down to the red figure in this case. So what we want to do, and so the way I always do it is kind of like ordered pairs. So I count, right or left first and then up or down. So in this case, if we start at this point, I'm going to go over 1, 2, 3, 4, 5, 6. So I'm going 6 to the right, and then 1, 2, 3, 4, 4 down in this case. So if I were to actually, if this red dot wasn't here, then what I would do is I would take these corner points of my 5-sided figure and move them those appropriate number of points. So in this case, I'd start here. So let's say this is A. So I'd go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. And lo and behold, there's my A prime. And then if I called this B, I'd do the exact same thing. So I'd go over 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Here's my B prime. Oh, this is a 4-sided figure. What am I talking about? Quadrilateral, sorry. And then just do the same thing. If this is C and this is D, then this would end up being C prime, and this would end up being D prime. So our, well, I just wrote it down below. I should have wrote it up above. So our translation rule in this case is 6 to the right and 4 down. Or if you wanted to think of it as kind of that ordered pair notation, you could think of it as 6, -4. So however you want to write it, it's up to you. So at this point, pause the video. Work on practice 2 for me. And so notice, we've got some different slide arrows going on here. So make sure you move all these different shapes around. If what I'd probably do, I'd probably recommend, go through, label these points so you can actually label like the A prime, B prime, C prime, and D prime and stuff like that for each of these guys, and make sure we move them the appropriate way. And then when you've done practice 2, come on back. I'll talk a little bit about a mirror. Obviously, we don't have these at home, so we won't be able to do example 2, but we still kind of do something similar for the next practice problem. So when you're done with practice 1, come on back and we'll talk about a mirror real quick. All right, well, hopefully everybody did a good job with our translation. So a mirror is kind of a cool figure, and you may have seen one before. It kind of looks like it's a piece of plastic. It kind of looks something like this. I'm going to try to do my best to draw it. And so this piece in the middle is actually plastic, but when you kind of look through it, it allows you to draw the reflection of whatever's on this side onto the other side, so you can actually figure out where that mirror line is going to be and stuff like that. So in this case, like what we would do is we would stick our mirror somewhere here in the middle, and what I would do is I would look through it kind of in this direction until circle A was right on top of circle B. Once I found that, then I could trace right along where the mirror is located, and that's going to be my mirror line in this case. So again, it's kind of cool, but unfortunately we all don't have one at home, and I don't have one at the house either to even show you because they're all at school. But even without having a mirror, you can kind of get a rough idea of what these reflections would look like just by, kind of imagining, where would be the line that would actually allow this thing to fold up. So when you're thinking about a reflection, if you were to take a piece of paper and actually fold these two pieces on top of each other, that crease in the paper would actually be that mirror line. So like for part A, it would kind of look about there, and then part B, same thing, it would kind of look something like that. So again, if you were to fold up that piece of paper, the two rectangles would line up with each other and the crease would actually be the mirror line. So again, this could be a little tricky to try to do without the mirror. So if you want to give it a shot, if you're pretty artistic, feel free. If you're not up for it, I've got ones that we can do that are on dotted paper that makes it a little bit easier. So, but again, that's kind of unfortunate that we didn't get to play around with the mirror, but that's okay. All right, so let's do some reflections where we've got dotted paper or graph paper so we can actually do it. So again, with the reflection, the goal is this object's going to be flipped around some mirror line. And so in this case, this is our mirror line. And so again, we're doing the same thing. We're trying to move points A, B, C, and D to points A prime, B prime, C prime, and D prime. And so the thing that we want to look for is when we're trying to calculate A, we want to figure out how far away it is from that mirror line. Well, the cool thing is, notice what happens if I draw this line from A to the mirror line. What can I say about that angle that's formed between the mirror line and that line? So hopefully somebody yelled out perpendicular, and that is exactly true. And so that's one of the cool features that you get when you're working with reflection. So every point on the graph is perpendicular to the mirror line. So that's the way it's going to help you figure out, where the new point is. So in this case, if I count from A to the mirror line, I've got 1, 2, 3, 4. So that means what I want to do is stay on that same line, 1, 2, 3, 4. And that's going to give me my A prime in that case. And then same thing for B. So I have to count over 2 to get to the mirror line. So 1, 2 takes me to B prime. So C is just like B, it's 2 away. So if I count over 2, that takes me to C prime. And then D looks like it's 3 away. So that gives me D prime. So again, pause the video at this point, do these reflections on your own. So again, same idea, label the points, somehow, however you want to do it. Reflect them over, then relabel the new points, A prime, B prime, C prime, D prime, whatever you get. And then when you're done, unpause the video and we'll talk about a rotation in this case. All right, so how'd everybody do with reflection? So hopefully that went fairly well. So rotation, so again, what you're going to have is there's going to be a center of rotation, which again, in this picture, and pretty much all the ones that we're doing, like, well, they're a point A, but typically they'd be about where the origin is for these guys. And so what you're going to get is that's going to be our center of rotation. And again, these can be tricky for folks because, like I said, sometimes it's a little harder to do the rotation. So I recommend, if you aren't sure about if these rotations are correct or not, do my Ziploc bag trick, where again, like in this case, red is the image. So like if I were doing this as a Ziploc bag, like I would take and draw the axes just to kind of help me. And then I would trace the figure on the Ziploc bag. And then I would take this point and, first I would move it over there. And then if I needed to keep moving it, I would just keep moving it around. So this point's always going to land on one of the axes. That's kind of the thing to remember, because we're not going to rotate like 45 degrees or anything like that. All of our rotations are either going to be 90, 180, 270, or 360 and stuff. And so in this case, when I rotate, if I rotate this thing 90 degrees counterclockwise, I'm going to land exactly on this figure. So another thing that you'll want to notice, and this will help later, so notice point A is 1, 2, 3, 4, comma 0. And what is A prime? 1, 2, 3, 4, 0, comma 4. So that's another thing to notice. So notice when I switched from, after I did the rotation, the X and Y coordinates kind of flipped on these guys. So that's something I hope you'll notice as you're going through all these translations and stuff like that. There's going to be nice patterns that occur. I didn't want to give them to you because there is going to be an activity that kind of does them yourself. So, but that kind of gives you a little hint on that one. So in this case, what direction was this rotated? And from point A to point A prime. So in this case, again, there's two different answers because this was rotated 90 degrees counterclockwise, or 270 degrees clockwise for this guy. Now, you don't have to come up with both answers. Like, if you only noticed it was a 90-degree counterclockwise rotation, that's fine. I only care if you get one of them, so keep that in mind. All right, so pause the video at this point, work on practice 6. So again, notice all of these guys that are less than like 90 tell us about which direction. So why does it just say rotate 180? Why doesn't it say clockwise or counterclockwise? Yeah, because it's the same. So, because it doesn't matter, because the nice thing about a 180 rotation, it's going to be the same whether it's clockwise or counterclockwise. So you can rotate it either way, and we'll all end up with the same answer. So that's why doesn't specify which way to rotate a 180. So you really only need to know like the 90s and the 270s and stuff like that. All right, so when you're finished that, come on back. And this is what I was talking about with the ordered pairs and stuff like that. So I wanted to make sure you had a chance to work on these and practice moving just the points around and then seeing if you can come up with a pattern for what it is. So that's what the last one is. P of x comma y is a generic pattern for how a translation is going to move any of these points in general. So we've got one for a translation, we have one for a reflection, and then we've got one for a rotation counterclockwise, and then we've got one for a rotation clockwise, and then that's it. So we didn't get the glide reflection today, so that'll actually be in the next section. So, but take your time and really work on these practice 7s and stuff like that, 7, 8, 9, and 10, because these are useful to know, because if you can learn the tricks of how these ordered pairs move around, it helps you in terms of being able to visualize what the pictures are going to look like and stuff like that. So at this point, practice everything that's available. If you have any questions or anything like that, just let me know. Otherwise, I'll see you guys tomorrow. So good luck.